Hi, this is a video on scientific notation. It's really important in all sciences for writing out very large, very small numbers, but we often use it for numbers of all sizes. So let's go through what scientific notation is, and let's do a few examples. So if we take a look at this number here, 855.2 nanometers, that's a normal number. We call this standard notation. It's 855.2. This quantity here, 0.0000540 coulombs, is also in standard notation. One to the left of the decimal point is the ones place. So that's the normal way of writing things. Down here, we have the same quantities written in scientific notation. Now notice for both of these quantities, we have this coefficient times 10 to the some integer. This coefficient between 0 and 10, or between 1 and 10, times 10 to some integer. So if we want to convert between standard and scientific notation, here's what we're going to do. We're going to take a look at this decimal point, and we're going to move it over so that there's only one digit in front of the decimal. So we're going to move it over right after this 8 here. Pen input isn't great, so we move that over 2 places. And then we're going to write out that new number, 8.552, which is what we have right here, times 10 to the something. Since I moved the decimal place over 2, it's either going to be plus 2 or minus 2 in this exponent. Since I moved it to the left, it is positive 2. And I'm going to add the units as always. Same thing down here. We move the decimal place over until there's only one non-zero digit in front of the decimal. 1, 2, 3, 4, 5 places. So we write out our new number, 5.40, times 10 to the, well, it's either going to be plus or minus 5. In this case, since we move the decimal to the right, it becomes minus 5 instead of plus 5. And there's a way you can check yourself to make sure that your exponent changes in the correct direction. Because in scientific notation, we're actually writing the same number. So since the number part here got smaller, then the exponent has to get bigger by the same amount. In this second case, the number part got bigger, so the exponent has to be smaller. So we have a negative exponent there. That's essentially scientific notation. Coefficient between 1 and 10, not including 10, times 10 to some integer. Now, when you're solving problems on a calculator, you're going to be using scientific notation a lot. There's a shorthand for scientific notation that's often used on a calculator. It's called E notation, or it's really just scientific notation using E. And E stands for blank times 10 to the blank. So if I wanted to write 8.552 times 10 to the 2 in my calculator, I could do 8.552, this little capital E, 2, and that would give me the same exact value. And your calculator is often going to spit out things in that format as well. On a TI-84, the way we get that E notation is we do second comma, and it'll be written out as double E. And it will just be written literally like 8.552, little capital E, 2. For our second quantity, 5.40 times 10 to the minus 5, we write it as 5.40 E minus 5 on a calculator. Now, one thing you want to be careful about is this is a capital E, and it's written on your calculator. The button is 2 little capital E's. It's a capital E because the capital E is important because lowercase e is actually a different constant in math. In math, it's equal to Euler's constant, 2.718, repeating, or not repeating, but it goes on forever. And in physics, it's equal to the charge on a proton. So it's really important that you use the capital E, not lowercase. So let's just do a few quick examples converting from scientific notation and back. Number 1, convert 218,000 square meters to scientific notation. Let's take a look at our number. We're going to move the decimal place 1, 2, 3, 4, 5 spots. So we're going to write that as 2.18 as our coefficient times 10 to the, since we moved to the left 5, our exponent is plus 5. And our units are meters squared. There's our answer. Number 2, convert 5.90 times 10 to the minus 3 kilograms to standard notation. Notation is written twice. Well, we're going to do the reverse process here. 5.90 times 10 to the minus 3 means we're getting smaller by 3 decimal points. So we're going to move our decimal place to the left 1, 2, 3 spots. Add the zeros there. We get 0. There's going to be 1, 2, 2 zeros in front of the 5, 0.00590. Our units are still kilograms. I added that 0 at the end because that's going to leave the number of significant figures the same. We'll talk about significant figures in a different class. Number 3, convert 0.000000577 grams to scientific notation. Again, we're going to move the decimal place 1, 2, 3, 4, 5, 6, 7, 8 places. So we're going to write out 5.77 times 10 to the, since we move to the right 8, it's going to be times 10 to the minus 8 grams. And this number really illustrates how useful scientific notation is, because that's really small and kind of obnoxious to write out all those zeros. Last example, convert 7.56 times 10 to the 6 meters to standard notation. Well, we're going to move the decimal place. Since it's 10 to the 6, we're going to end up with a bigger number, so we're going to move the decimal place to the right 1, 2, 3, 4, 5, 6 places as we get rid of that 10 to the 6. So we're going to end up with 7, 5, 6, and then there's 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. That is 7,560,000, and the units are meters. That's all on scientific notation. Bye.